Okay, back to this problem here. We have 2g minus 10. Okay, so 2, and what can multiply? You're thinking about what can you multiply to 2 to get to 10? Well, it would be 5. And 2 times g, you're not going to put 2 inside again. So 2 times g gives you that 2g. 2 times the 5 gives you 10. So you have factored. Factor is a number that can go into the numbers that go into the number that you're looking at. Okay? Just like the 10. The 2 goes into it. That's a factor. 5's the factor. Can you factor a negative 2x plus 6 to get the negative 2 parentheses x minus 3? I said yes. When you factor out a negative 2 from the negative 2x, you get x. See? Here's your negative 2. You factor it out. Here's your x inside. When you multiply this, it gives you back to that negative 2x. And then when you factor out a negative 2, you ask yourself, okay, what times the negative 2 is going to give me the 6, which is your 3 here. Okay. And, of course, it would be like negative 3. That is, add the opposite. This is a negative 3, so a negative times a negative does give you the positive. Okay? And then I would like for you to work the number 3, reflect. Okay, on page 311, we have our graphic organizer here dealing with writing equivalent expressions involving rational numbers. And our term is term, our vocabulary term. So, in my own words, a term is a number, a variable, or the product of numbers, variables, and or expressions. Okay, an illustration here. We've got 32 plus 10a plus 6a. Well, you have 32, you have 10a, and you have 6a. Are all terms of the expression that is written here. Okay. I would like for you to fill in for the examples and the non-examples. And then on number 2, it says, Aiden says that equivalent expressions always have the same number of terms. Is Aiden correct? If he is, explain why. If he is not correct, give a counterexample. So give us an example of, Okay, on to page 312. We have Jake cuts out 5 pointed stars. They are different sizes, but they all have the same shape. The side lengths within each star are the same. To find the perimeter of each star, Jake uses the expression, all of this, 12L plus 1/4 minus 4L minus 8.5, or 8 5/10, if you want to say, plus 2L plus 8, where L is the side length of the star. And yes, you would write a cursive L, because if you don't, then it's going to look like a 1. Find the perimeter of a star with side length 6 inches. Okay, so I've written out the expression again. Then I went and put all my like terms basically together. I've got all the ones with the variable, the L. And when it's got minus 4L, you make sure you put minus 4L plus 2L, whatever the sign is that's in front of it, okay? Then there's the 1/2, and there's a minus 8.5 and plus 8. So when you 12L minus 4L gives you 8L, and add the 2 gives you 10L. And then you have 1/2 and 8, which gives you 8.5. And then you're going to subtract 8.5, which gives you 0. Well, it told us the side length here was 6 inches. You put this into the parentheses, and 10 times 6 gives you 60. So your final answer here would be 60 inches. Okay, I guess I didn't pause that on there. All right, on this is check your answer in problem 3A. What I did, I went back in and put the 6 where the L was, and gave the answers to each